Okay, so we've got a pulley system here, okay, whereby two masses, okay, are suspended on this string system, okay. So you've got mass A of 3.1 kilograms, so the weight is going to be 3.1 G, okay, and of course then we're going to have tension then in the string holding that mass in place, and then we've got the other end of the string, a mass labelled B here, whereas the weight of that will be 1.8 G, okay, because it's got a mass of 1.8 kilograms. We've got the tension there, okay. Now, initially it says it's held at rest, and then it's released, okay. So the string is taut, it's released, and it says calculate the magnitude of the acceleration of A and B and the tension in the string. So it's held at B, then released. Now if it's released, because that's the heavier object, the pulley system is going to make the weights here, we're going to ensure that B goes up, okay, and A goes down, because A is the heavier. So A will go down this way, it'll pull the string down, and B will go up the other way. So we're accelerating in this direction, okay, with regards A, but with regards B, of course, then the string is going upwards, okay. So if I use Newton's second law, okay, in the direction of motion, okay, so along the string effectively, okay, at A, you've got the weight here, take away the tension, okay, so that's the resultant force, isn't it, using Newton's second law. You've got the weight taking it down, but the tension in the string resisting it from falling, okay, okay, pulling it back, okay, but it's still falling, you're just not falling under gravity, so to speak. So you've got the resistance of tension in the string. That will equal then to mass times acceleration, and the mass is 3.1 and the acceleration is A, okay, so that's formula 1, or equation 1. At B then, so if we resolve at B, now at B it's going upwards, so the tension in the string is of course greater than the weight of the object, of the mass, okay. So T, take away 1.8 G is equal to 1.8 mass times acceleration. So in order then to work out acceleration and tension, we solve these simultaneously, and if we add them, what happens is the tensions disappear, okay, the tensions will eliminate, because minus T add T is 0, isn't it? Minus T add T is 0, so we've got to put these together, add these together, so we've got 3.1 G, add then this, which is minus 1.8 G, is those two added together, so that's 4.9A, you put them together. Work this out then, so you get 1.3 G is 4.9A. Remember then, G is 9.8, okay. So then to work out A, you just take the 4.9 over and divide. That will give me my acceleration. For my calculator, if I work that out, I get out to be 2.6, okay, that's my acceleration there, 2.6 meters per second squared. All you've got to do then is sub it into one of these formulas, one of these equations to work out tension. So I put it into, so sub into tension, take away 1.8 times G, which is 9.8, okay, equals to then 1.8 times the acceleration, which is 2.6. So the tension then will become 1.8 times 2.6, okay, which is 4.68, and of course then you've got to take that over the other side and add it on, so you get 17.64. So tension, when you add them together in string, is 22.32 newtons.